You see, we don't have much time to do a lot of examples, but I've shown you the calculation, the basic calculation, the steps to do that. I've shown you two methods on how to do the calculation. So either way, the next thing how you want to understand is by you practicing, by you trying out different ways. That's the only way you can do it. Now bear in mind that we have to catch up a lot, and therefore please do spend at least 2 hours every day studying by copy. If you have any doubt, please ask. For those who missed a lot of classes, you may have a lot of problems. Of course, I'm trying to upload videos. Video conversion is taking a lot of time. So I'll try to do that as soon as possible. So we're going to continue our rotate instructions. Rotate instructions is actually quite easy one. So basically there are two rotation instructions, one is rotate left and one is rotate right. And when you take this is rotate left. There are two types of instructions for rotate left. One is rotate left through carry, another one is rotate left not through carry. So rotate left means you rotate every single bit by one position to the left. Now the first instruction, rotate left through carry. This one, it actually goes through the carry. So let's say for example, this is a 5 register extent and you have 8 bits right. So let's put in some dummy value inside this. And assume that in initial condition we have these values in carry and also this value in the 5 register. Don't worry about why this instruction is rotate through carry. There is a reason for that. But for now, I want you to understand how it works. Rotate through carry means like this, rotate through not carry means like that. So we're going to see how it actually works. So understand the principle. So if you're going to apply this instruction, which is rotate left through carry, this has 3 fields, right? FDA. So the address of the 5 register is hex 10. Of course, the destination should be F. And since this is how we write instruction. So when you execute this instruction, this is rotate left. Rotate left means this is left right. So every single bit will rotate left. But this one rotate left through carry. So from the diagram itself you can see how the rotation is being happened. From the carry, that single bit will be pushed to the least significant bit. And therefore every single bit will be pushed by 1. And what happens to the most significant bit? That will be pushed to carry. This is quite relatively simple, right? So in this case, when you perform the rotate left, what happens is, whatever inside the carry comes here, everything is shifted by 1. And this one will be shifted here. So when you do the rotation, you'll have a new value like this. So this is what we meant by rotate left through carry. Are you able to understand? Yes. Any question up to this point? Now regarding the paper which I've handed over to you, please check if there's any mistake in the calculation or if I missed anything. If you have that, please come and see for correction. This is rotate left through carry. There's another one, rotate left not through carry. Let's take the same 5 register so that you can see the difference of one rotating through carry and one without carry. So the same data 1, 0, 1, 0, 0, 1, 1. So the instruction is going to be rotate left, not through carry. Like this. So this one, it only rotates within its file register only. Rotate. So everything going to rotate to the left. So the least significant bit will start rotating here. It will come here, come here, this will come here, 0 will come here. This one will come here, this one will come here, this 0 will come here, and this one, what will happen? It enters here. So one is through carry, one is not through carry. Is it okay? Yeah. It's quite simple, right? For now, I want to understand how it works when you rotate. Any question on this? So that is rotate left. The next thing is rotate right. The same principle. The only thing is now the carry bit is actually positioned on this side, because when rotate left, you will start to push from the most significant bit. You all understand? Because rotate left, you need to push everything from here to here, to the left. Rotate right means you should push from left to right. So that's why the carry bit is positioned on the other side. So likewise, the same principle, it will all shift by 1. And the same thing also with rotate right, not through carry. Everything will be shifted towards the right. Any question on this? No. I don't think so. I need to show the example for that because it's the same. Is it okay? Yes. Okay or not? Okay. See this example. I think one of the past years or one of the tests they have asked is, compute the new values of the data register hex 10 and the C flag after the execution of rotate left hex 10 or here's hex 10 instruction. Given the initial content of hex 10 is A9 and the initial condition of the carry bit is 1. So this is initial condition. This is correct, but this is wrong. It's supposed to be 1 here. It gives the C is 1. So there's a mistake here in the slides as well. So how would you solve such a question? By drawing the file register, and you say A9 means this is A, this is 9, and the initial should be C, should be 1, right? So when you rotate left means right to left. From the carry bit should come like this, right? Push from left, from right to left you push. So if this is through carry, so the carry bit should come to the least significant bit first. So you'll push, and the last one should enter. So this value is actually wrong. Okay, assuming that this is the A9 and C1 is the value, can you do now? If you rotate left, what is the actual value? Yes.
Just want to ask, because on the right hand side, right, I noticed that the carry just now was on the right, whereas at the left, for rotating left, carry was on the left. So does it mean that the carry goes to the direction in which the...
It makes it easier for you to visualize. That's why the position. So, yes, Stephen.
This diagram with the carry is right and left. Example 2.19. Carry is left.
Doesn't matter.
But the principle is the same.
Yes. Doesn't matter if it's here. When you rotate left, this rotate left. So when you rotate left, whatever in the carry, remember whenever it's through carry means whatever inside carry should be pushed first. So rotate left means whatever inside the carry should be rotated through the left first. Rotate right means whatever inside the carry should be pushed towards the right first. It makes it easy when you put it in this way. Or for rotate left, you put it that way. It makes it easier. Because for the rotate left, you put this side in, easy like this. But in this diagram, it is this side. But it doesn't matter. From here, you have to bring it, push it. So through carry means always the carry will push first. So what is the real value? There's a mistake here. So if A9 and C is 1, what is the value?
The last two values.
That's one.
202 on what in front?
What's the value?
Any volunteers or shall I pick? Share in front, or what's the problem? Who want to do? I want to ask who want to do, no one want to look at my face. Can we sit closer? Who want to do in front? Please come and share. What's the value, Sasi?
Ya, beza carry kat kanan dengan belah kiri sama je. Sama je. Cuma kalau through carry push first lah.
Or the initial value and then rotate to the left. No, don't put the carry is not 0, it's 1. A9. A9.
Same. 1 0.
1 0 1 0.
1 0 0 1.
You know, rotate left to carry. So what's the new value? The last one should go back into carry, right? Just put it a bit further lah, like put it very close, you get confused. Not that one, that's correct. The most significant bit. That one put it a bit further. Yes. So you don't get confused. So, what is the content of carry? Content of carry after you perform rotate is 1. What's the new value? You know what's in next?
5 3.
So I cannot see.
5
It's 5. Everyone get the same? So likewise, the example 2.20 is also the same thing. So I hope we can try it out. Any question up to this point? Yes or no? This is quite one of the easiest ones. You can take it. So the same thing with example 2.21 and also 2.22, but this time around it's without carry. So it's much more simpler, right? You're just going to rotate among itself only. So this is much more easier to see. So I think you can try out this example. Is it okay? It's quite relatively easy. So this is on the rotate right and rotate left, not to do carry. So in order for you to solve this question, you only need to know direction. You only need to know where is left and where is right. But trust me, sometimes during exam, students do forget where is left and where is right. It happens. Okay? Can we move on? will come and see this later. Now we want to see the application of this rotation. Now of course this rotation left and rotation right, you can use it later on in the LED part when you learn in chapter 7, you can have a running light. When you rotate that single bit, when you rotate, you can have a running light. You can do that when we go to chapter 7. But there is also another application for rotation. Let us see how it actually, how can we apply this rotation. Now let's take a binary number. Assuming this is the content of a file register, that is, let's focus on the content. Now when you actually rotate this to the right, rotate this to the left, everything moves to, this is rotate means within its file register. Rotate to the left means everything gets shifted to the left, right. So what will be the new value? This one will be shifted, everything will be shifted right. 1, 0. So it will be 0, 0, 0, 1, 0. Right? Yeah. Then if you shift left again, this is our reference or original number. So this is when we rotate left. What happens if we rotate right? This one when you rotate right. Okay, this is right. If you rotate right again. This is what you get when you rotate to the right. Now, what is this value in decimal? 8. 8. 0, 8. 8. Decimal, not hex. This one? Hex. 10. This one? In decimal. 0. This one? 32. What is this one? 4. What is this one? 2. What is happening here and what is happening here? What is happening here? What's happening when you rotate right? What is left? Huh? I know the value is getting bigger. What is the relationship? Yes, it's a multiple of 2. Each time you rotate to the left, you are multiplying by 2 each step. So if the initial value, if it's 8, if you rotate to the left, the next value that you get is 16, which is 8 multiplied by 2, 16. Then the value 16, if you rotate to the left again, you get 32, which is 16 multiplied by 2. So whenever you rotate to the left, it gives an effect of multiplication. We are multiplying by 2. Likewise, I think you can figure it out on the right side. It is actually divide by 2. So this is one of the applications of rotation. You can perform multiplication and also division without even using the multiplication instruction. Can you understand? Of course, I have given a simple example. But there are few rules that you have to abide. Whenever you want to actually perform multiplication, you notice one thing, that the most significant bit will actually enter here, right? Which is the least significant bit. In order for the multiplication to be true, the most significant bit must always be 0. Because if the most significant bit, if it's not 0, when you rotate, the 1 comes here, means it becomes an odd value. Whenever you multiply 2, you cannot get an odd value. Do you understand? I'm just telling, so it's up to you whether you want to write down or not. For example, let's say this value 1, 0, 0, 0. What is this value in decimal? 1 to 8. If you perform rotation to the left, what happens? It becomes 1. Is it the correct answer? No. So this is what I meant by you can multiply any number by 2 by rotating to the left, but as long as the most significant bit of the number must be 0. So if the most significant bit of the number is 0, yes, you can perform the multiplication and you will get the right answer. If it's not 0, if it's 1, see when you multiply you get an odd value, which is odd and also wrong. When you multiply 2, you cannot get an odd number, you only can get even number. Can you understand? Any question up to this point? Yes or no? So likewise, when you divide, this also holds the same rule. The least significant bit must be 0. Why the least significant bit must be 0? Can anyone tell me? Why the least significant bit must be 0 for division? Right. Why when you want to perform division, why must the least significant bit must be 0? Yes, you can only divide even number. The least significant bit must be 0 because this is not a float binary number. So we cannot so if 1 divided by 2 you get 0.5, but you cannot represent 0.5 here. So when you want to perform division for a non-float binary number, the binary number must be even. So even number means the least significant bit must be 0. So in order for the division by 2 to be true, the least significant bit must always be 0. Like for example, this one still you can divide, right?
Yes.
If you rotate, you get 1, which is correct. But 1 if you divide, you will get 1 to 8, which is wrong. Can you understand?
Yes.
Any questions?
No.
So, let's take one example. Can I erase this one? Let's see this example. It says multiply the content of hex 20 by 4. Now first when you see this, first try to identify, you are required to do multiplication. So multiplication means rotate left or rotate right.
Rotate left.
Yes, it's rotate left. So it says multiply by 4. So how many times do you need to rotate?
Twice.
Twice. Because one time you rotate is multiplying by 2. 2 times rotate is multiplied by 4. 2 times 2. So this one is a single byte value, right? So for a single byte value, you just use rotate left not through carry. You don't have to use carry. All the examples we did is not through carry, it's just within 5 registers. So first time you do and the answer must be stored at its own destination. When you do this one time it's multiplying by 2, but you say multiply by 4. So you rotate again. So it's multiplied by 4. Is it okay? Anyone understand? Any question? So likewise, if they ask to divide by 8, divide by 8 means rotate to the right how many times?
4.
Not 4, 3. 3. 4 is 16.
2.
Okay, so you get the idea, right? So no.
Repeat.
Which part?
Just now.
Which one? The divide one.
Ah.
If you want to divide by 8, how many times do you rotate? First divide means rotate to the left or right? Right. How many times? 3. One time you rotate is 2. Second time you rotate, 2 times 2 is 4. Third time 2 times 4 is 8. Get it? So sometimes the question will ask you to do this multiply by 4, but some students what they tend to do, they tend to use multiplication, then they get wrong answer sometimes. If they ask to do multiplication like this 4, 16, 8, 2, just use rotation. If they ask to multiply the content of a value with another 5 register, then you use multiplication instruction. You understand? If they say multiply the content or divide the content by 2, 4, 8, 16, 32, something like that, you just use rotation. If they say multiply the content of this file register with the content of this file register means, that one you have to use multiply, MULWF instructions. Or if they say multiply the literal value to working register means you have to use 1LW. Is it okay? Now, this is for multiplication and division for 1 byte. What if you want to do more than 1 byte? Can I erase this? Yes. Anyone say that? Like I think this one. Perform multiply the 3-byte number stored at hex 000102 by 8. So now the value is no longer 1 byte, it is 3-byte value. And you want to multiply the 3-byte value by 8. Multiply means rotate left or right?
Left.
So it's rotate left, right?
Left.
So let me just put in some dummy value inside. Now we're supposed to rotate left, but it's supposed to rotate left everything, you know. But there is a problem. You cannot use rotate left not to carry. Why? Why you cannot use rotate left not to carry? Because this part. When you do rotate left not to carry, this one, this 0 actually goes back here, right? You understand what I'm trying to say? By right, this 0 is supposed to go here. Everything is supposed to be shifted to the left, right. That means this one should come here, this one should come here, this one should come here, this one here, this one here, this one here. This one should actually go here, right?
Yeah.
Because you need to shift everything by 1. The problem is how would you transition this bit to here? Using the rotate left not through carry, you cannot do that. So that's where the rotate through carry comes in. So you use rotate left through carry, extend F and A. So what happens? You have a carry bit here. Now remember the rule, that whatever that enters here, because you rotate left means whatever that enters into the least significant bit must be 0. So in order that for that condition to be true, you must always make sure that the carry bit initial value must be 0. So you always have to bit clear F status register comma C. So that because each time you need to make sure that carry value that enters the least significant bit is 0. You understand? So when you do rotate left through carry, before you do this you must make sure that you must do this. You must bit clear F status register C. You must always do that. So then when you rotate carry, what happens? The 0 here actually enters here, right?
Yes.
What happens to this 0? This 0 will be pushed into carry. You are following? Then when you do this one, rotate left through A. The 0 which actually pushed into carry now comes where? Comes here, right?
Yeah.
So this is pushed correctly. So the carry is actually used to transition the 0 from the most significant bit to the least significant bit. So likewise here also will have carry. So this one everything will be pushed by 1, and this one will push back.
Carry.
Will push into
Carry.
carry. And then here when you perform rotate left to carry X to 8, what happens? This most significant bit which is pushed into carry now
Carry.
is being pushed here, right?
Yes.
So everything else being pushed. And this 0
Carry.
is actually being pushed into the carry. So what happens this part? You transition through carry come here, this one to carry come here. So at every time you perform the multiplication, in the beginning part, this one should always be
0.
initialized to 0. So this is one round. This one round, rotate left, rotate left, rotate left. You multiply how many times already?
3.
How many times have you multiplied now? The whole 3 by?
3.
Just multiply by 2 only. Don't get fooled, huh? You see, got 3 doesn't mean you multiply 3 times. You are just, these 3 instructions for 3 bytes. So one time you run this 3, you are only multiplying by 2. Not 2, 1, 2. So you need to rotate this whole instruction how many times? You multiply by 8 means?
3.
You need to rotate this 3 times. Remember the sequence, this is always applicable for the single byte you have no problem, right? I told you for the single byte, if you want to perform the multiplication or division, you must make sure that, for example for multiplication, you must make sure that the most significant bit is always 0. For the division, you must make sure that the least significant bit is always 0. That's for single byte. Is it clear? For more than a single byte multiplication, you always must make sure that the carry is always clear for either case, whether you're performing division or performing multiplication, because whatever inside carry is what will enter into the least significant bit or into the most significant bit. And this instruction, rotate left, rotate right, rotate left, depends on how many bytes that you have. In this case, we have 3 bytes, so you need to perform rotate left, rotate left, rotate left. 3 bytes means you have 3. But when you write this 3, you're only multiplying by 2. You need to repeat this 3 times, then you multiply by 8. So therefore, we put it in a loop. This is what we did, right?
Yeah.
Clear? Rotate left, rotate left, rotate left. This is one set of multiplying by 2. This whole thing we need to repeat
3
3
times.
times. So what they have done, move 3 into the working register, and then they decrease the content of working register. As long as it's not 0, it will perform the loop. So once you perform 3 times, it will go out of the loop. So at the end, you'll have multiplication of 8.
8.
Is it clear? It's quite finance. The same thing also applies for the division. Same thing. Exact same thing. If for multiplication the 0 is entering this side, means for division the 0 will be entering into both. Anyhow, you must make sure that the status register is always 0. In this case, divide the 3-byte number stored at hexstat 11, 12. 10, 11, 12. Only got 3. 3. But it say divide by. Suppose we divide by 60. If we have 4 times looping means divide by 60. So take note, if it's 3-byte means you'll have 1, 2, 3. If you have 2-byte means you only have 2. If you have 4-byte means you'll have 4 instructions. The number of loops determine that what is the value that you want to divide or multiply. Do you understand? If you're just going to multiply by 2, no need loop lah. Just one time enough. Then if you want to multiply by 4, then you just loop it 2 times. You understand? So with that, we are done with chapter 2. The next chapter we're going to go is the chapter 7, which is a parallel input-output port. So I'll take attendance. So please try this. You can try this in MPLab. You can see the you rotate, you can see the answer. And someone stop recording. Rosalie, use that? Rosalie, can you stop recording?
Off. Mana?